Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam IFM, Investments in Financial Markets. You own one share of a non-dividend paying stock. Because you worry that its price may drop over the next year, you decide to employ a rolling insurance strategy, which entails obtaining one 3-month European put option on the stock every 3 months, with the first one being bought immediately. You are given a continuous compounded risk-free interest rate is 8%. The stock volatility is 30%. The current stock price is 45. The strike price for each option is 90% of then current stock price. Your broker will sell you the 4 options but will charge you for their total cost now. Under the Black-Scholes framework, how much do you pay your broker? And here's the solution. So let us first calculate the current price of a 3-month European put option, with strike price being 90% of the current stock price S, with K equal to 0.9 S, R equal to 0.08, the risk-free rate, sigma, the volatility of the underlying, 0.3, and T equal to 1/4, we obtain D1 in the Black-Scholes formula would be equal to the natural logarithm of S, no dividend involved, so this is the prepaid forward price of a stock, over 0.9 S times e to the minus 0.08 times 1/4. That's the present value of exercise price. Plus 1/2 times 0.3 squared times 1/4 over 0.3 times the square root of 1/4. And you can see that S cancels, so we can actually calculate this to be approximately 0.9107. D2 is equal to D1 minus sigma square root of T, and that's approximately 0.9107 minus 0.3 times the square root of 1/4, and that's approximately 0.7607. And then we're working with put options, so we will need n of minus d1, which is n of minus 0.91, approximately, and that's 1 minus n of 0.91, and that ends up being approximately 0.1814, and n of minus d2, which is n of minus 0.76 approximately, that's 1 minus n of 0.76, and that ends up being approximately 0.2236. And then we use the standard formula for the price of a put, the Black-Scholes formula. So this is present value of exercise price times n of minus d2 minus prepaid forward price of a stock times n of minus d1, and that ends up being 0.9 S e to the minus 0.02 times 0.2236 minus S times 0.18814, and we end up with approximately 0.0159 S. So you see that the put price ends up being just constant times the price of the stock at time 0 for this put. For the rolling insurance strategy, we will have 4 such puts, and the costs are 0.0159 S of 0 at time 0. And then if we do the same calculation at time 1/4, it will be the same calculation for the next 1/4 of the year, so that will be 0.0159 times S at 1/4 at time 1/4, and then at time 1/2, 0.0159 S of 1/2 at time 1/2, and then 0.0159 S of 3/4 at time 3/4. Their total price at time 0 is the sum of their prepaid forward prices. Since the stock pays no dividend, its prepaid forward price is S of 0 for any time of a forward maturity. Hence, the sum of the 4 prepaid forward prices is just 0.0159 S of 0 times 4 And we are given S of 0 is 45, so this is 0.0159 times 45 times 4, which is 2.862, and that's answer C. Please remember, this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.